Hi class, welcome to this video on the rule of 4 part 2. In this video I'm just going to go over how you can complete a couple pages, pages 18 to 23 from your tips booklet. The first page is really just review. This is stuff you should have learned in the previous unit and should be familiar with by now, but I'm just going to go over it so anyone who is unclear about any of this can get clarification. So the first problem we're given is we want to fix our car and we're going to take it to Joe's garage where he charges a base fee of $25 and he charges $40 an hour. And it says make a table of values of the cost of fixing a car for each hour up to 4 hours. So the first hour we're going to start with is 0, then we're going to do 1, 2, 3, and 4. How much is it going to cost us to fix the car if we have 0 hours? We just taken it in, we want to get it fixed, we're going to get it fixed, but we haven't actually had them do any repairs yet. How much is that going to cost us? It is going to cost us the $25 base fee. And then it's $40 for each hour. And so for the first hour, I'd have to add $40 to my base fee, and that would give me 65, 25 plus 40. And for the second hour, again, I'm going to add another $40, so I get 105. And for the third hour, I'm going to add another 40 and I get 145. And then finally, I end up with $185 for the cost of 4 hours. Then it says using your table from A, calculate the first differences. And so we'll just be copying, again, this right here the exact same way. And now it's just asking us find the first differences. Well, what's the difference between 25 and 65? It's 40. Between 65 and 105, it's 40. Between 105 and 145, it's 40. Between 185 and 145, it is not 140, but 40. And then it says here, rate of change. Now, because this is going up by 1 each time, our first difference tells us the rate of change right away. But sometimes this value here is not going up by 1, and that's when this becomes more important. We could do it here now. So look, the first difference, the difference in C, what was the difference in C? It went up by 40 each time. What was the difference of H? It went up by 1 each time. So 40 divided by 1, and we get 40. That is the rate of change. When this column goes up by 1, when the pattern in the X column is 1, then the first differences tells us directly our rate of change. When it doesn't go up by 1, we have to use this formula in order to find out the actual rate of change, and you'll see that momentarily. So question C has us graph the cost of fixing a car for up to 4 hours, and I've already graphed that here just to save us a little bit of time, and you can see that these points would reflect the points that we outlined up above. So this is 0 and 25, this is 1 and 65, this is 2 and 105, this is 3 and 145, and this is 4 and 185. And you can see I've graphed it there, so you can also graph it on your handout. D asks us to identify the rate of change and the initial value and what they mean in this problem. And so the rate of change, as we saw in the table of values, was 40. But what does that 40 mean in this context? It means the cost is $40 per hour for repairs, right? And then what about the initial value? The initial value we saw in the word problem, because the garage charges $25 as a base fee and then $40 per hour. So that initial value is the $25 and it's for the base fee. And another way we could write this is we know M now is equal to 40. We know B is equal to 25. And that's going to be helpful as we determine an equation to model the graph. When we do the equation, we write the equation as y equals mx plus b. And therefore, our equation is going to be, if we do C for cost, M is 40. That's our rate of change, or our slope. X is time measured in hours, so we can put H. And B, the initial value, is 25. So we get C is equal to 40H plus 25. There's our equation. And it says determine the cost of a 2.5 hour repair job. Show your work using the equation from part E. Check your answer using the graph from part D. So if I use my equation, here's my equation, C equals 40H plus 25. I substitute in for H 2.5 plus 25. And then I multiply first. 40 times 2.5, that gives me 100. And plus 25. And I get 125. And it says now I could use the graph to check, couldn't I? So 2.5 is here on the graph. And if I go up like this, yeah, it's about 125. Here's 120. And there's 125. So I verified using the graph. What does the point 6265 mean? We don't have that on our graph, but we can imagine. Remember, the 6 is the independent variable. In this case, the independent variable is hours. And the dependent variable is cost. And so what this means is for 6 hours, Joe's Garage charges $265. If it costs $155, how long was spent working on the car? All right, so again, this is a question where we're going to use the equation we came up with. C equals 40H plus 25. Now, instead of being given the number of hours, we've been given the cost, so we can substitute in for C, 155. And now, this is a basic two-step algebra question. I need to subtract 25 from both sides. I get 155 minus 25 equals to 40H. 155 minus 25 gives me 135. Equals to 40H. And now I need to divide both sides by 40. Divide both sides by 40. And the answer is 3.375 hours. Okay, so that's how much it would cost. How many hours you would get have spent in the garage or getting repairs if the cost was $155. So now looking at the next page, we're looking at planning a special event. And according to the question, Maxwell's Catering Company prepares and serves food for large gatherings. They charge a base fee of $200 for renting the facility, plus a cost per person based on the menu chosen. So they have 3 menu options. The first one is menu 1 is a buffet that costs $10 per person. Menu 2 is a 3-course meal that costs $14 per person. Menu 3 is a 5-course meal that costs $18 per person. Now keep in mind, with all 3 menus, they still have the $200 for renting the facility. So now we're going to fill in the table of values, and they're nice. They've given you the equations that we're going to be working with right here. So we'll work with these equations. You can see menu 1 is C equals 10N plus 200, because you have the 200 for renting the facility plus 10 people. Well, if you look at these tables of values, you'll see the values in the X columns are not just going up by 1, so you have to be careful about filling them out. In this one, n goes up by 25, and the second one, n goes up by 50, and in the third one, you'll be given the option to make it go up by whatever you like. And I'll leave that for you to do. What I'm going to do here in this part of the video is just help you to fill in the first couple of tables of values, and then you should be able to complete the rest of your handout on your own. Whatever you don't understand, of course, you can always text me or leave a message on Google Classroom, and I'll address it there. So let's look at this box right here in the first tables of values. It says here, what is the cost? And we're trying to find out the cost for 25 people. Well, if I substitute 25 here in for n here, so I get C equals to 10 times 25 plus 200. this equation is what's going to give me the cost for 25 people. And it's 10 times 25, which gives me 250, plus 200 gives me 450. So that is $450 that I'm going to put here. What if it was 50 people? I would do 10 times 50 plus 200, and I would get 10 times 50 gives me 500 plus 200 equals 700. So this is 700. Now how much did this go up by? It went up by $250, and that's easy to see because 10 times 25 is 250, and we're adding on this side 25 each time. That's why it says going up and is going up by. Right? So that means we could do this equation again if we wanted with the number 75 in there, but a quicker way to do this would be to just simply add 250 to 700 and get 950. And if we add 250 to 900, we get 1200. And if we add 250 to 1200, we get 1450. And we should see that our first difference is over and over again 250. Now, does that mean that the slope of this line is 250? No, because what we should be looking at is the change in x, the change in y, which was 250, divided by the change in x, which was 25. 250 divided by 25, 10. That is our rate of change. That is our slope. And we could see that in the equation as well. But I just wanted to make that clear that if this y column is not going up by 1, then what we have to do is we have to divide the first difference from the y column by the pattern in the x column. So the first difference was 250 divided by 25, we get 10. That's our rate of change. All right, so let's do the next one. The next one is 0, 50, 100, 150, 200. And so if we do that one, then what we find that 0 people is going to cost us 200, right? If we substitute in 0 for n and multiply it by 14 here, then we get 14 times 0 equals 0 plus 200. Now, what if we want 50 people? So C equals 14 times 50. We're using that equation. We substitute into it plus 200. And if we do 14 times 50, we end up getting $700 plus 200 equals to $900. And so here I can write $900. This one is going up by 50. 50 times 14 is equal to 700. So this changed by 700. And the next one also is going to change by 700. So we get 1600, 700, 2300, 700, $3,000. All right. And again, does that mean that the rate of change is 700? No, we would do 700 divided by 50. And when we did that, we would get 14. That is your actual rate of change. All right, so now you're going to do this one, and I recommend, and you don't have to, but I recommend do this by 75. Okay, and fill in the cost and fill in the first differences. You're also going to do this graph, and I just want to explain one brief thing about this here. It says explain whether to use dashed or solid lines. And technically, and we haven't really done this in much detail, you should be using dashed lines. And the reason for that is that, you know, the dashed lines represent that in between whole numbers, the values are meaningless. And what do I mean by that? Well, I could have 1 or 2 guests, but I can't have 1.5 guests, right? And so if, for example, on my graph, I have here 1 and 2 and 1 and 2, and this is not for this particular graph, but I'm just trying to explain this idea of the dotted lines. If I say I have a line like this, see, this point right here is actually 1.5, 1.5. But in a case where this is measuring the number of people and this is measuring the cost, the idea of having 1.5 people is completely meaningless, right? And so when that's the case, we should be using dashed lines, okay? So if you want, I mean, you should be using technically dashed lines. We haven't been doing it thus far, but when you make your graphs, you use the lines as dashed lines, and that's because, you know, the values in between the whole numbers are essentially meaningless. You cannot have 1.5 people, for example, going to your party. Okay, so that explains the dashed lines. You do need to complete the rest of the pages in this handout. Do the best that you can. If you have any questions about it, please feel free to ask, and I'll be happy to help you. And if enough people ask the same question about ask about the same question, then I'll make a quick video just to address that specific question. I hope that clarifies everything that you're going to need to know. And like I said, reach out if you need any help.